So something that is pretty neat about moving charges, so whether that's a positive or a negative charge, is that it creates a magnetic field around it. Okay, so let's say we just have an electron. Okay, so this thing is some electron. Okay, and let's say this thing is moving to the right with a given velocity. Okay, let's say it's a constant velocity, so it's not accelerating. Now, something kind of cool about this is actually going to create a magnetic field that surrounds this electron. And we are going to have the ability to determine the direction of that magnetic field. How do we do that? Well, we are going to use what's called the left-hand rule. Okay, now our left-hand rule is quite useful. Notice left hand, you're going to use a left hand when you're talking about a negative charge. Anytime you do these rules, this always applies. A negative charge, you use your left hand. A positive charge, you use your right hand. Other than that, everything stays the same. Okay, that being like what your thumb represents, what your fingers represent, so on and so forth. So in this case, your thumb, okay, your thumb will actually represent your vector of your charge. Okay, so which way your charge is going, so the direction. In this case, it is to the right. So I'm going to draw a really bad hand. Okay, so I hope you're ready for this. It's going to be a really bad hand, but that's okay. So your thumb should be to the right now. Okay, and that's the direction. It's pointing to the right. Now, how about your magnetic field? So your magnetic field is going to be represented by your fingers. Okay, and your fingers are going to wrap around this electron. So your fingers represent the magnetic field lines. Okay, so they're going to wrap around. So this is a little bit more difficult to draw, but what you're going to do is you're going to take your fingers and you're going to wrap them kind of around what you're talking about here. So it'll be boom. Very bad drawing, but that's okay. A little scary, but we'll make it through. Okay, so that means your magnetic field will actually go around like this. Okay, and then around like this, around like this, so on and so forth. An easier way to represent this is using your dot and cross representation. So a dot means it's going into the page, and a cross is, oh, sorry, I messed that one up. A dot is out of page, okay, and an X is into the page. Now, how am I going to remember that? I already have enough things to remember. Well, think of an arrow, whether it's coming towards you or away from you. If an arrow is being shot towards your face, all you're going to see is a point, so it's coming out. If you see an arrow going away from you, you're going to see the feathers, so you're going to see an X, so it's into the page. So how would I represent this? Use your left hand, point your thumb in the direction that which the negative charge is going, and then wrap your fingers around. So on the top of the electron, the magnetic field is going in to the page. My goodness, it's going into the page. And on the bottom, your fingers are going to wrap back around and come out of the page. So you could also represent your magnetic field something like this, which is a little bit more easier to understand. Okay. Now, how about if we have a wire? Okay. So let's say, if you think about it, a wire, if you have a current, okay, let's say going this way, that's exactly the same thing as a bunch of electrons moving this way. Okay. So you use the exact same rule for a wire. You just have multiple of these electrons, or say if you have a positive moving current, then you use your right hand. So let's do an example where we have a wire, Okay, and we're looking into the wire. Okay, so we have our wire, the top of the wire there. And let's say the current is moving out of the page, so towards your face. Okay, so how would I do that? This represents our current. Well, remember, that's a bunch of electrons. I'm going to say negative current I. Okay, let's say that's a bunch of electrons coming towards us. So you're going to use your thumb, and you're essentially going to point it towards your forehead or however you're looking at the screen, okay? And you're going to point your thumb out of the screen, and your fingers are going to wrap around that wire. So a magnetic field is going to go surrounding this wire in a clockwise position. So that's how your magnetic field would surround that wire. Let's say you have a positive charge. So positive currents are known as conventional currents. Okay, let's say we have a conventional current doing the same thing. Okay, so this time this is a bunch of conventional currents. So what does that mean? Well, conventional current means it's a positive current. So this time you got to use your right hand with that rule. Okay, so I'm going to use my right hand. I'm going to put my thumb pointing up out of the screen because that's where my positive charges are going. And then my fingers are going to wrap around the wire and form a counterclockwise magnetic field. Okay, so these are the applications of the left hand and right hand rule. We've learned that a moving charge creates a magnetic field, and we've learned how to determine the magnetic field lines when that is occurring.